software, it emerges from your mind to the laptop, and it is as though it came straight down from heaven. And it's fantastic. It works perfectly, it's concise, it's well documented, it's like, oh my gosh, that's the kind of software that everybody should have a chance to see, right? So when you were working on homework number 1, at no point in time did you see a red script on your screen that said, oh yeah, no, you can't do that.
Ever.
Oh,
Ever.
no.
Ever. Nor when you're working on homework 2 will you ever see said thing. Or will you ever run the program with no red script, okay, that's good, and then get completely the wrong answer. Right? That's not going to happen to you, because you're better than that. Well, okay, that's cool, but for the rest of the world, guess what? It is an issue, okay? So the question is, well, so how do we get sort of like from where we start with version 0.0 to version 1.0? Look, as the developer, you're the person who's responsible for delivering software that does what it's supposed to do. Initially, when you write it, they'll probably be wrong, and all that errors. You'll get it better and better and better and better and stuff like that. So what we want to talk about is how you actually get there, and that's called testing. It's not glamorous, it's not exciting, but in all honesty, it is a career. There are people who do nothing but software testing, and they're actually really, really quite good at it. You can hand perfectly good working software to them, and they'll break it in less than 20 minutes. So. All right. So let's talk about the fact that things happen. Okay, so here it is. On your laptop, you create your software, you make your changes, you do your testing, everything is perfect. You're done, you're finished, you're wrapped up. It's Friday, it's 6 o'clock, woohoo, all done. So you go ahead and you check your code into the central repository. The problem is, as you're getting checked in, something happens. What happens is somebody else checks your code out, and what they discover is that your code doesn't work. First concept is, well, there's no possible way that can happen, right? Come on, because it worked here. How can it not work here? That doesn't make any sense. And the sad truth of the matter is, it's actually really quite common. The reason it's common is because on your laptop, you have a particular environment in which you're running your code. So you've got files that are available, you've got maybe, libraries that you've linked to reference to, you have a particular operating system, you have particular plugins, or whatever the story is. You've got a particular environment, and in that environment, your code works perfectly. When you check it in, the code's no longer in your environment. When somebody else checks your code out and tries to run it, they're running it not in your environment. It's entirely possible that they will now discover that something doesn't work right. Okay? So you need a safety net. Okay, let's talk about this. Okay, so how do problems show up? So we've talked about our configuration management tool, right? We check code in, we check code out, keeps versions, does all this tagging and all that sort of stuff like that. We talked about a build tool. Remember we talked about build scripts and this big complicated thing where it makes sure that it grabs this and compiles this and compiles this and then puts it all together and produces stuff. So we've got all these wonderful tools. Now configuration management allows you to back changes out. Whoa, we're not going to include that in this release. Fine, back it out. Build tool ensures that the code compiles. Now remember, creating software can be complicated, but when you do it using a build tool, it always does it exactly the same every single time. This is wonderful stuff. But with all these put together, still you can produce software that flat out doesn't work. Oh, jeez. Just sort of throw your hands up type of time. Okay, well, let's see what we can do about solving that particular problem. Okay, so there's 3 different ways to look at your software. Remember, if your software doesn't work, okay, nobody's going to use it. Hey, I've got a version of Microsoft Word, but it doesn't really, save files. So you can type in it all you want, but you really can't save what you're doing. That's fantastic. I'll use something else. Thank you very much. If it doesn't get used, of course, the saddest thing in the world is you're not going to get paid. Okay? So I will not pay you for software that doesn't do what it's supposed to do. There's just no value in that. So clearly we want this scenario to not occur. Look, you've got 3 different users that you're basically dealing with who will see your software. Obviously there's the users. These are the people that you got your user stories from, thus the users, right? They're the ones who say, listen, I would like to have a program that will allow me to come up with a website for my shack that's on the middle of the pond, right? Now there's another group of people that we haven't really spent a lot of time talking about, that is the testers. So these are people who work for your company, okay, who do nothing but test software. It is their job to verify that the software that you're getting ready to give to the users actually works correctly. And then, of course, there's developers. And you are a developer, but there's also, you've got peers. You've got other developers who can look at your code through the eyes of a developer and say, yeah, you did a good job, or what were you thinking when you did that, right? So different people look at your software differently. When you test your code, you have to consider the fact that all three of those groups will look at the software that you've produced just a little bit differently. Okay, so how do users, the people that you're actually delivering the software to, how are they actually going to look at your particular software? Well, what's interesting is they're not going to see the beauty of the comments that you've worked into your code. They'll never see it. In fact, they won't see the code at all. Okay, I'm a user. I use Microsoft Word. I have absolutely no idea what language it's written in. I have no idea how big it is, and I've never seen this code before. Okay? And I don't really want to see any of the code for Microsoft Word because I really just want to use Microsoft Word. My code is basically, your code will be what we call in the industry a black box to the customer, right? So it's a box, and it's a box they cannot open. They cannot look inside. They cannot see if it has whirling, spinning gears, moving parts and stuff like that. The only thing they can do is see that it's a box. And they can see the box has goes ins and the box has goes outs, and that's it. What goes on inside the box, what goes on inside your code, is a complete mystery to your end users. Okay? And from their point of view, either your homework, number 2, works or it doesn't work. Right? And they'll show that from the outputs, from the inputs and outputs. If I give it this input, I expect this output. Does it do that? Okay? Users are all about product functionality, and they don't care about anything else. You could write sloppy code, you could write bad code, you could write big code, you could write slow code. As long as it basically does what it's supposed to do, end users fat and happy. Got no problems with that whatsoever. Okay, but end users aren't the only people you have to deal with. You also have to worry about testers. Now, gentlemen, once again, testers are people who work within your company. And their job is to take the software that you gave to them and determine whether or not it's ready to be handed off to users. Okay? They're looking for functionality just like end users' butts. Okay? They poke around under the covers. Okay? They know what the software is supposed to do, but more importantly, they also sort of understand how it's going to do it. So they understand where they can poke and prod and potentially get your software to break. Right? Your code is what we call a gray box to them. They don't really look into it that far, but they can open up the cover. They can look in and they can see how the various piece parts are connected. And when they see how things are connected, they know that where things generally break is where two things come together. When they see two things, your code and my code, when they see our code coming together, that's an area that they will end up testing heavily. Because they know that that's a good possibility something's not going to work there. Okay, testers look into the database. So yeah, your code, generally speaking, in the real world, will work with some sort of database. So they'll take a look at your code, they'll take a look at the database, and they'll make sure that the two of them are playing together nicely. They'll make sure that you're updating the database correctly, there's nothing weird's going on. And then there's a whole bunch of other things that code does. You might be using some network resources, you might be using some memory resources. When you're done using it, the question is do you do a nice job of cleaning up after yourself? And testers will pound on your code over and over again. They'll run it and run it and run it. What they're looking to do is to see if you're using up memory or if you're being sloppy, leaving things open and sort of sprawled all around. Okay? Because if that happens, they'll go back and look at you. Okay? Now, other developers can potentially take a look at your code also. Okay? Unfortunately, the issue with developers is that they actually will take a look at your code and they'll come back and they'll give you the harshest review of all. Right? If you didn't do a good job of commenting, if you did a lousy job of picking your variable names, or you just have sloppy code, developers are going to call you out on it. Okay? Your system's wide open to them because they're actually looking at your source code. Other developers will see everything that you have. Okay? We consider this to be what we call white box testing. Where not only have they popped the top of the box open, but they've actually reached in and taken all the bits and pieces out and laid it all out on the table. And they're taking a look at all of it and saying, that gear's too big, you're using the wrong piston, and why did you make it a diesel engine? You could have made it a gasoline engine, right? They're calling you out on pretty much all of your design decisions. They may say it's a good design decision, or else they're going to say it's a lousy one. Okay? Now, developers are pretty good, but also developers, just like everybody else, can be blinded by the details. Wow, you used that SQL statement? That's the wrong SQL statement to use. Stop. Move it up a level. You know, think about the functionality. And developers don't do that, and that's why testers are also important. So let's talk about this black box testing. Remember, this is the type of testing that generally that users have to do. You see the functionality, but you can't see how the functionality is done. Okay? Users are obviously located outside your system. They're not actually in. They can't see the code or anything like that. They only see what they put into your system, and then obviously the output that your system produces. Okay? So it's the goes ins and it's the goes out. And that's it. How you do what you do, the magic that your software does, is completely hidden from users. Okay? So when they're doing these types of testing, the number one most important thing to them is, does it do what you promised it would do? You know, Microsoft Word should allow me to enter text. It should allow me to save it as a file, and it should allow me to print it. I mean, at a very fundamental level, that's exactly what I want it to do. There's a lot of other beautiful functionality I like that it has, but you've got to do its core functionality before anything else. So there's user stories. Remember, oh my gosh, we've just been living with those user stories forever and ever, okay? In theory, your software should do exactly what those user stories were. What do we have? Let's say I should be able to accept payments in MasterCard, Visa, and PayPal. I should be able to reserve, obviously make a reservation. I should be able to pick my view. I should be able to pre-order food. I should be able to set up a boat tour. So those are all the user stories that I better be finding in your software. Okay? That's what you promised me, so when I get the software, it is better to do it. How do you store your data? Whether you store it in an object-oriented database, a regular database, whether you store it in an Oracle database, I don't care. I really desperately don't care whatsoever from a user point of view. Okay? Basically, data goes in, story results come out, that's what I'm looking for from a user point of view. But users are looking for more than just functionality. Look, they're looking for user input validation, okay? So this is actually one of the things that we're discovering in homework number 2, right? So if a user puts in bad data, what does your system do? Male or female? X. Great. There is no X, okay? Okay, so tell me what's going on there. So your system has to react correctly to no matter what the user tells you. If they can type it, you gotta handle it, right? Okay? And does it do it gracefully? I'm sorry, you appear to have made a mistake. Would you like to re-enter that? Or does it do it horribly? Error 15, done. Wait, what? What? And I think we've probably seen all of those, right? Yeah. Software that does nasty job. Right. Okay, output results. Now here's the trick on this one, okay? You know, depending on how complex your program is and stuff like that, it may produce beautiful looking results that just might be garbage. Okay? So whenever you're running a program, one of the first things you have to do is you always have to hand check any sort of numerical results. They may look beautiful, but are they actually the right results? You have to test all the functional paths. Remember, every time you have an if statement, you've got 2 paths, right? If you have a while statement, you have got 2 paths. You might do the while, or you might not do the while. Same thing with fors and stuff like that, right? So you've got a lot of different paths that can go through your software. You really want to test all of them to make sure that they all work correctly. And when you're doing that, that's a pain in the butt to do. So oftentimes it'll help you to create a table, okay? And say, listen, I expect my inputs can have males and females. I expect my inputs can have young people and old people. I think my inputs can have people who live in Lakeland and people who live in Orlando. Let me go ahead and make sure that I enter data that runs through all of these different scenarios and make sure that the system actually is able to deal with all this. There's something else called state transitions, okay? So this is something that occurs inside the software. So your software might work one way if this is the set of inputs, and it might work a completely different way if this is the other set of inputs. I guess a good example of this might be like tax software. So if I have a tax program, fantastic. Okay, are you preparing taxes for you as an individual, or are you preparing taxes for you as a business? Okay, will you make a decision? Depending on which way you're doing it, it's going to have completely different functionality. So you need to double check to make sure that the software moves from state to state. Okay, so do your business processing or do your individual tax processing. You expect, this is a little bit different from output results, you need to make sure that the states are actually being switched. And when I say I'm going to do it as individual, it doesn't do any of that business stuff. And likewise, when I say I'm a business, it doesn't do any of the individual stuff. Okay? Once again, creating a table of what kind of states are involved, making sure that the system actually moves from state to state is critical there. And finally, what we like to call boundary cases. So whenever there's something where you can enter a value, okay, go ahead and test what the largest possible value is, and then test a slightly larger value, just see what the system does. Same thing if there's a really small value, test the small value and something even smaller than that, just to make sure that the system's not going to eat itself when you pushed it to the edge. Huh? So here's an interesting question for you. How would you black box test your homework number 1 input? So you're a user. You cannot look into the code. You can't see any of the code. You know that these are the inputs that the system accepts. If you're going to create a black box test, how would you do it? What would your test be? Have somebody else use that. Well, that's true. I guess that, you know, if you're too smart, right? Have somebody who doesn't know anything about the thing use it and see what they actually do. So that's one way to do it. But specifically, what tests would you create to test your homework number 1 to make sure that it works correctly? So we can start with the very first one. Please enter last name. What kind of test did you have for that? I can think of 2 right off the bat.
Is there a really long name?
Super long name, right? We're going to come up with like 300 characters. Bam! I'm Mr. Well, let's see what it does, right? Does it like, whoa, that's too much? And actually, interesting enough, that's oftentimes how security vulnerabilities in systems are found, right? What happens is if you enter something too long, and then everything beyond like 256 characters, you can put in your secret command structure, and it will actually execute it. So crazy stuff can happen. But yes, that's a great one. Now, flip side of that is what? Too long is one thing to do. What's the opposite of that? Which would be nothing, right? What happens if I enter nothing? Woo! Okay, you're Mr. Nothing, right? Okay, so those are both good. Now, look, I got a beautiful Mr. Johnson. What else could I put there that would test it? Does it have to be alphabetic? We could try numbers. We could try goofy characters too, right? It's pretty much any character I can possibly get that keyboard to crank out, right? Let's see if it handles it, right? So okay, so we push it. We can do the same thing for first name. There's no problem with that. Now middle initial, how long do you think a middle initial is? You would think so, right? So what happens when you enter 2? Right. Push it a little bit. Street address, I think street address would probably be length. Oh, too long or too short. Same thing with city and state. Zip code is supposed to be how many numbers? You would expect 5, right? So if you're black box testing, how many are you going to put in? 6 or more, right? Let's see what happens when you do that. Okay, does it have a problem? Now, I'm not exactly sure what the valid range for zip codes in North America is, but I don't think there's any place that's like all zeros, right? Hey, what's your zip code? Oh, 0, 0, 0, 0, right? So not only, there's also 5-digit number sequences that are not valid zip codes. Let's go ahead and enter one of those and see what happens, right? Is this thing doing a check against some sort of master zip code database to make sure it knows what's going on? And more importantly, enter a zip code that isn't Lakeland, Florida, New York City, or something like that. Let's see what happens. Let's see if the thing's smart enough to go, wait, that zip code is not within the city limits of Lakeland. Okay. So we've got male, female. So what do we do there? This is pretty simple stuff. Basically, yeah, right? So any character besides an M or an F. Then what else could we do? Make it longer, exactly. And we could also put nothing at all. Let's see what happens. Cool, that's pretty good. Date of birth. Now we have a fixed format here, right? Month, / date, / 4 digits for the year. Simplest thing to do is to do the year 2 digits, right? 15, bam, see what happens, right? Next thing to do is to leave out the slashes, right? Maybe enter some text, January 1st, 1900, whatever. So you can do a lot of different things there. Have insurance is a yes or no, so we don't point yes or no and see what happens. Social security number is expecting to be 3 digits, a dash, 2 digits, and then a dash, and then 4 digits. Pretty easy to do anything but that, right? Make it too long. Put in some alpha characters, A, B, C, D. Okay, and Medicare ID, we never really specified what that was. we'll say it's 10 digits, so we can push it to 11 or take it down to nothing. Story is. So you get the gist of it. And actually, people spend a lot of time doing exactly this type of testing, okay? So these are all the inputs you're going to take. I'm going to see if I can break it. Now, the code that you wrote for homework number 1, could it handle it if I put in something besides male and female? Sure, it'll take whatever you gave it, right? Woohoo! Thank you very much. Could it handle it if I put in a zip code that was more than 5 characters? Yeah, go ahead and enter whatever you can with those, right? Because it wasn't really part of your requirements to make that any tougher than it had to be, right? So, all right. So now let's talk about what we call the gray box testing. Remember, gray box testing is the type of testing that testers at the company that you work at will be doing. Now, under gray box testing, they can open up the lid and see your software. Specifically, they can see where your software interfaces with other software. So that's a prime area that they do want to test very heavily. They can also see when you interact with the database and stuff like that. So they can't necessarily see every line of your software. They're not really looking at your source code that way. But they are taking a look at your chunk of software, and they're seeing what other chunks of software your software talks to. And the reason they're doing that is because from a testing point of view, testers realize that the place where you're going to have the greatest problem is when you have 2 pieces of software talking to each other. So the test cases that they develop are going to focus on those areas to see if there's any problems in exchanging information. So, gray box testing is required. You can't get results out of the system without looking inside it, at least a little bit. So, you might have some sort of analytical piece of software that does world weather forecasting or something like that. That's not really producing an awful lot of output. So the question is, what is it actually doing? In that case, gray box testing is critical. Good example would be web apps that move data around in a database. Think about ordering from Amazon. There's not that much output when you order from Amazon. There's a ton of stuff going on behind the scenes, right? I gave you my credit card number. I said I wanted to have that book or whatever. And then now you're going to go off and go to your factory, go to your warehouse, and say that I have my address, and then we get that particular book. So you want to go ahead, if you're testing Amazon software, you want to go ahead and double check and make sure that all that stuff is working. You need to check both, in that case, you have to check both the database and the web code. So does the Amazon software do a good job of asking me for my information, asking me for my credit card information? Yes, it does a good job. Cool. Now go check the 25 databases that my order actually impacted and make sure that each one of those databases got updated correctly. If you're doing anything that has to do with money, auditing and logging becomes critical to what's going on. Okay? Auditing and logging, you're not going to be able to see it from the outside. You're going to have to actually dive into the code. Okay, so I brought in $1,000 and then I split it into 2 separate accounts. Well, that's fantastic. But you better be logging that and telling me that you actually did that, okay? And generally you'll do that, either there'll be a log viewing tool, okay, here's what the log looks like, or else there's going to be some sort of auditing report. But generally that's not going to be available to end users, okay, because it's secret inside stuff that's actually going on. And actually, in order to audit and log stuff, you may actually have to do some queries of what's going on in the database, because ultimately that's going to tell you what the final story is. Gray box testing includes doing things like data design for other systems. If your software puts together a complete patient record and then hands it off to the billing system, fantastic, that's wonderful. As a gray box tester, what I want to do is take a look at the format of that record that you're handing off to the other system, because I want to make sure that you got it right, okay? His software is going to crash and burn if you got it wrong, but it's not his fault. So I'm going to try and take a look at exactly what the format of that record is to figure out if I have any issues like that. System added information. So the system might be adding some stuff to the information that's already there. Checksums. Anybody know what's a checksum? Good question, apparently. Okay, so if I have a database of social security numbers, that's a lot of numbers, right? The question is, so are those, okay, and then, so I have it there, and then tomorrow I come and take a look at my database of social security numbers. And the question is, did anything change? I don't know. Okay, maybe I send my database of social security numbers to you. Great, now you have it. Did you get it correctly, or did something change in transit? I don't actually know. Well, how could we find out? Well, we could compare every single number that I sent you. Wow, what a pain in the butt, okay? Right. So here's a better way to do it. It's called a checksum. And added them all up. That's exactly right. So if I took every social security number in that database, and if I added them all together, I would get a number that's way too big, right? All right, that's fine. It would roll over, right? Ching, 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 ching. So if I added up all my social security numbers, I would get a number. If you added up all your social security numbers, you should get the same number, right? And we would have some level of confidence that you got the same database that I have, right? That's exactly what a checksum is. So it's a computed number across a group of data that says, good news. This data is exactly the same as this data if you can calculate the same checksum. Generally, checksums are set up so that you can determine if there was 1 bit off or 2 bits off between the two data sets and stuff like that. You can spend a lot of time doing checksums. So hashing is sort of the same concept, basically making sure that this data set is valid, that nothing has changed on it. If you can recreate the same hash value from the data, then it's all valid. You also want to double check things like timestamps. Timestamps will come back and bite you every single time. Okay, you want to make sure that you have actually the right time of day, and also time zones. Oh my gosh! And actually, the thing that always catches me is whenever there's daylight savings, because all of a sudden you're an hour off. What happened there? Oh wait, stop. Daylight savings. And remember, some places, even in the U.S., don't observe daylight savings. Indiana. Parts of Indiana, Arizona, they've just decided, well, we're just not going to do daylight savings. Well, okay, great. What time is it there? All right. Then there's the concept of scraps, and this is another big area for gray box testing. As your program runs, it's probably using resources, temporary storage areas to do stuff, like, for example, sorting and stuff like that. The question is after it uses it, is it cleaning up after itself? Okay? If you're not cleaning up after yourself, there might be a security risk. I'm going to put all the social security numbers there, and then I'm going to sort them, and then I'm going to store the sorted numbers. Fantastic. That's wonderful. Did you get rid of the ones where you stored it before you sorted them? Otherwise, you're leaving a bunch of valid social security numbers out. Okay? You need to check for memory leaks. What's a memory leak? I mean, are we talking stuff actually on the floor? Are we going to have to get like rags? It's like, oh my God, what happened here?
This program keeps pulling memory but not letting it go.
Okay, that's exactly right. Okay, so memory leak is when your program says, I need to have a little bit more memory to do what I'm doing. And so the operating system says, great, here's a little bit more memory. And your program says, oh, hey, could I have a little bit more memory now? And it keeps asking and asking and asking, and it never gives the memory back.
The newest version of Android, the operating system has that bug. So it kills off the program, but the operating system causing it.
There you go, exactly right.
It keeps slowing down until it crashes.
And so if you have a memory leak, what's going to happen eventually?
Well, whatever program this is goes down.
You're going to run out of what?
Memory.
Exactly. Over time, you will run out of memory. Okay, and actually, this is a memory leak's actually pretty common. Anybody use the Firefox web browser? Yeah, you just leave that up for a couple days, and guess what? You got to kill that bug because it's got memory leaks all over the place. Okay? And so you'll find it runs slower, and eventually it sort of seizes up, and it will actually eventually die because it has memory leaks that will use up all of it. Okay? Verify that after uninstalling your application that you leave the system clean. You guys know about Windows Installer. If you run the little installer and it updates the system registry and all that sort of stuff like that. Great, that's how you put it into the computer. What happens if you remove it? Hopefully it cleans up after itself and gets itself out of the registry or stuff like that. But yeah, so this is exactly the kind of stuff that your testers will double check to make sure that they're correct on. Which then leads us to question. So how would you gray box test your homework number 1 output? So you can actually look into the code now, okay? And you can sort of take a look and see what kind of things that you, so we've got a patient name, street address, and this is all sort of just echoing what you got. But now we've got things like age, right? So if you wanted to gray box test that age, what would you do? Do the old date and sort of see what happens, right? That's the one we got. Well, an interesting thing is how many digits do we have there? 2. So I guess what you probably want to do is see what happens if you put 3 digits, right? Or 4 for that matter, right?
See what happens if you put a date for future.
Exactly. Does this patient have insurance? You want to go yes, you want to go no, and then you want to see what happens without. Your next biggest one here is probably going to be your encoded social security number, right? Sort of play some games with that, so see what the story is. Once again, I think you took what it was. So you had a number, you added it to 65, and you converted it into a character, right? So that's great, that's fantastic. So if you ended up with like something that was not an actual number, now you're going to start getting some weird stuff, right? The question is if you added a really weird thing to 65, could you cause it to go crazy? And the answer is yeah, you could. Because you get way out in that ASCII table, just strange things happen. And then a maintain ID, you probably can't do too terribly much with. So poke it a little bit around the edges, and that's basically what gray box testing is. So white box testing. Now remember, this is when you take your code and you turn it over to a developer. And the developer gets to see everything that you've done. Okay? Everything's laid bare to the developer. Okay? They know what's going into the code, and they try to break it. Okay? They're actively trying to break your code. So they're going to generate problem situations that will cause errors and crashes, and they know the code that they're going to be testing. So one of the things that they'll do in this particular case is they'll test all the different branches of the code. If I can look into your code, I will see every single if statement you have. I will see every while loop you have. I will see every for loop that you have. And I will see what the condition associated with that is. And so what I will do is I will create a test case that will test going this way and going that way in both of those cases. And what I'm trying to do is find out where your code's going to fall apart. Look at all the code, what data you need to provide to get it to take every path. That can be a real pain in the butt, setting up those test cases to get down into that one if statement and cause it to go both ways. Okay, white box testing also includes proper error handling. Okay, so this goes back to what we were talking about when we were talking about black box testing, right? When you get bad data, what do you do? Okay, so obviously hopefully the customer sees, please re-enter the data or something like that. The question is, what goes on inside your code? Are you handling the situation that you've got bad data correctly? Okay? Does your code clean up after getting bad data? Hey, here's a gigabyte of bad data. Thanks, I appreciate it. You know, that's garbage. Give me some better data. What are you going to do with that gigabyte? You're going to throw it away? You're going to store it someplace? Okay. Does your code work as documented? So if you take a look at the actual software documentation, which arguably could be your comments, et cetera, okay, does it do exactly what it is? Test each feature that's described in the documentation. And then, of course, remember, you don't run the world. You don't get access to every resource that you would like to have. Your program has access to some resources. So what happens if you run out of memory, if you run out of disk, or if you don't have access to a network? What does your program do? Die a horrible, terrible death? Okay, that's not so good. Okay? When you run into a problem, and every program will eventually run into a problem, does it handle it gracefully? Or does it just sort of seize up? Okay? You need to create tests to force those situations. So, here we go. If we wanted to do some white box testing of homework number 1 processing, so we have this, remember, if age was greater than 65, then Medicaid is input your Medicaid ID. So if we were going to do white box testing of that, what would we do here? What would we do with age? We'd make age be greater than 65 and less than 65. Would we also make it be 65? Dang straight, right? We got sort of 3 conditions there. And then down here, age is less than 18, so we probably do the same thing, right? We make age be less than and greater than, and we make it be straight on. There we go. Well, let's just make sure that it does exactly what it's supposed to do. And we would do that because we can actually see your code, can't we? So we know that 18 is a magic number and 65 is a magic number. So let's hammer your code on that. That's 3 different test cases in each of those. Creating tests. Okay, time to create some tests. So you have to determine what you're going to be testing, what to test and how to test it. Obviously, are the critical things here. What kind of tests can you create? You can test functional testing. Does it do what you said it was going to do? Performance testing. How much memory does it require? How much time does it require? Et cetera, et cetera. Boundary and edge cases. Remember, less than 18, greater than 18, exactly at 18. Race conditions. So if we're doing this and this at exactly the same time, is that going to cause problems? Are they both going to be competing for a resource? Are you opening up any security risks? Can you handle valid data? More importantly, can you handle invalid data? And so on, and so on, and so on. So it's almost unlimited what you can do as far as testing. You may need more than one way to test your data. Test the GUI, test the backend, and of course, always test the security of the program. Automating your testing is actually a critical thing. You want to create a library test. The thing is you create a test case. It tests your software. Double check to make sure some input is handled correctly. Yay, fantastic. Well, here's the challenge with that. You have to keep testing. Because remember, you're going to make more and more software. You want to keep coming back and double checking that somebody didn't mess up whatever that input was, right? Okay, so really what you want to do is take that test case that you created, which is fantastic and wonderful, add it to the list of all the other test cases that have been created, and then you'd like to make it so that all those test cases can be run against your software using some fantastic, wonderful automated tool that just takes it off the plate. Okay? In fact, you'd love to run all your tests with one command.
Run test.
Okay? And you always want to perform what's called regression testing. Adding bugs to existing code is called software regression, and it happens more often than you care to think. Okay? I made a little change and it screwed up something over here. Wow, you weren't even supposed to be doing anything. Oops, sorry about that. Okay? So really, you want to be testing all your software all the time. You're looking for something that's gotten messed up, and that's called regression testing. All right, fast testing versus slow testing. So if you have a really big test suite, okay, I've got 1,000 test cases. How long is it going to take to run 1,000? It could take a while, right? Depending on how long you're testing or something like that. But the thing is, not all tests take the same amount of time. Okay, great. So you can divide your tests up into fast tests and slow tests. And what you can do is you can say, listen, let's take all the fast tests, and let's just run them all at once. Okay? And I can run those every single day. I know I have some slow tests. Maybe I'll run my slow test once a week. Maybe I'll run my slow test over the weekend. But I don't want to take the time to run them all the time. Okay? You do need to run the full test suite when it's needed. And oh, by the way, depending on what you're working on, you may work some of those slow tests more into what you're running on a daily basis because they're critical to testing the functionality that you're currently working on. All right, we're going to probably end it on this one. So there's 3 different types of testing. Okay? And you will find groups out in the real world dedicated to these 3 different types of testing. The first one is what's called unit testing. Unit testing is the type of testing that you do as a software developer. Okay? As a software developer, you do unit testing. It says, my piece of software does exactly what I was told to make it do. Fantastic. That's wonderful. Now, you hand your software off to some people who do what's called system testing. And what they do is they say, we take your software and we take my software and we put it together. And when they're put together, this software should do something bigger than just your software. I'm going to test the system and make sure the system does exactly what the system's supposed to do. If it doesn't, that means either it's your fault or my fault or both of our faults. Okay? Now, after you do system testing, you then do user testing. In user testing, you put together the whole shooting match and you test it from the user's point of view. Does it do what a user expects it to do? Right? So there's really 3 separate systems. Generally, there's 3 separate computers. I'm going to store my code maybe on my laptop. I'm going to have a server where I'm going to do my server testing, and then I have maybe a lab environment or something like that where I'm actually doing my user testing. And we'll double check this real quick. All right, does that make sense? Are your brains full? Yes. All right, well, fantastic. We'll cut off right there. We'll take a break for about 15 minutes. We'll come back at 5 after. We'll do some Python. Sound like a plan?